Sanjay Bhardwaj from Department of Computer Science and Applications, DAV College for Girls, Yamunanagar. The topic of discussion in this lecture is logical gates, and we will be discussing three basic logical gates in this lecture. Now, the most important question is what basically a gate is. The word is gate. Gate is a logical circuit with one output and one or more inputs. The output is high for certain combinations of inputs. I said it is a logical circuit with one output and one or more inputs. The output value will be high depending upon certain combinations of input. The most important word here is certain combinations of input. This output will not be high every time. This will be high for some combinations of input. Question is which combinations? These combinations will vary from gate to gate. So, depending upon the type of gate, these input combinations will vary and the output will be high for those particular input combinations. We will start with the first gate, and that gate is OR gate. The word is OR gate. Definition is it is a logical circuit with one output and two or more inputs. The output is high when any one or all inputs are high. Again, I said it is a logical circuit with one output and two or more inputs. The output is high when any of the input is high. Circuit diagram. Now, the next in the sequence is circuit diagram. The circuit diagram for OR gate is, I am using this electronic component and this is called diode. Say one another diode, this is a PN junction diode, P for the positive part and N for the negative part. This is connected to output and output is Y. Two inputs, say one input is A and the another input is B. According to this circuit, there is one output and two inputs A and B. The device used is PN junction diode with this part as P and this part as N. The output is obtained at Y. The next is working. Now, in working, we will be going through the working of this circuit with different combinations of A and B. Say in the case 1, A is equal to 0 and B is equal to 0. When I say 0, this means low voltage. Now, this A is at low voltage, B is also at low voltage. When the P part is at the low voltage, there will be no current through this diode. The condition for current flow through the diode is this should be at the high voltage and N part should be at the low voltage. Now, since no input is connected to the N part, this is at low voltage. Now, A is 0 means A is also at low voltage. Both P and N are at the low voltage, so no current will pass through this upper diode. Similarly, B is 0, that means this P part is at the low voltage. This is at low voltage, no current will pass through the lower diode. The point is A is 0 and B is 0, so no current will be passing through either of the diode, and when no current will pass through the diode, the output at Y is going to be low, or I will say Y is equal to 0. That means A 0, B 0, Y value will be equal to 0. The next one is A is equal to 0 and B is equal to 1. Since A is equal to 0, this P part is at low voltage, this is also at low voltage, so there will be no current flow through this upper diode. But B is equal to 1, 1 means high voltage. So B is equal to 1, this part is low, this diode will be conducting. There will be current flow through this lower diode, and due to this current flow the value of Y is going to be high. A is equal to 0, B is equal to 1, no current flow through the upper diode, but since B is equal to 1 there will be current through the lower diode, and due to this current the value of Y is going to be high, or Y is equal to 1. Case 3, it is A is equal to 1 and B is equal to 0. Since A is equal to 1, that means this is at high voltage, there will be current flow through this upper diode, but B is equal to 0, no current will flow through this lower diode, but due to the current in the upper diode value of Y is going to be 1. Again A is equal to 1, due to this upper diode will be conducting and there will be current flow through upper diode, but B is equal to 0, so no current will pass through the lower diode, but due to the current in the upper diode Y is going to be 1, Y is equal to 1. And the last combination, and that combination is A is equal to 1 and B is equal to 1. A1, there will be current through this upper diode, B is equal to 1, there will be current flow through this diode. That means the current will be flowing through both of the diodes, and due to which the output is of the output Y is going to be 1. That means Y is equal to 1. Now these are the 4 possible combinations with 2 inputs A and B. Now first we said definition, the second part is the circuit, the third part is the working according to the different values of A and B. The next one is truth table. Now what is truth table? Truth table is a table showing all input output combinations. It is a table that will show all input output combination. So in other words, this is a summary of this working. I said 2 inputs A and B and the output value is Y, and as per the truth table, when A is equal to 0 and B is equal to 0, the value of Y is 0. I hope this one, A is equal to 0, B is equal to 0, Y is equal to 0. A is equal to 0, B is equal to 1, Y value will be equal to 1. This is the second one, A 0, B 1, Y is equal to 1. A is equal to 1, B is equal to 0, Y value is equal to 1. And the last one, when A is equal to 1, B is equal to 1, the value of Y is equal to 1. Now these are these 4 different cases, different values of A and B. 0 0 is 0, for 0 1 it is 1, for 1 0 it is 1, and for 1 1 it is 1. I will be back to the definition. It is a logical circuit with one output and 2 or more inputs. The output is high. This is very important. The output is high when any of the input is high. In this case A, B was high, so Y is equal to 1. Here A is equal to high, that is Y is equal to 1. Here both A and B are high, that is why Y is equal to 1. So next, after truth table, it is symbol. What is the symbol of this? This gate is represented by the symbol, this one. This represents OR gate in Boolean algebra. This symbol is for OR gate. The next one is significance. What is the significance of this in Boolean algebra? OR gate represents addition in Boolean algebra. This represents the operation addition in Boolean algebra. Now whenever we will be using Boolean algebra and the symbol plus will be used, that indicates there will be gate and that gate is going to be OR gate. Next in the sequence is AND gate. We will be moving in the same sequence. That means we will start with the definition of the AND gate. Again, it is a logical circuit with one output and two or more inputs. A logical circuit with one output and two or more inputs. The output value is high when all inputs are high. This is very important. In AND gate, the output is going to be high when all inputs are high. Circuit diagram. So, in the circuit diagram, again we will be using diodes, PN junction diodes. But the very important is, if you see the diagram, I am using it in the another direction. Here the P part is going to be connected with the high voltage always. This input is A, this input is B, and the output value is Y. Again the definition, it is a logical circuit with one output and two or more inputs. The output will be high when all inputs are high. So, two inputs, there will be four working combinations. The first combination is A is equal to 0 and B is equal to 0. This is the first one. A is equal to 0 and B is equal to 0. Now, very important is this A is connected to the negative part. This is at the low voltage, but the P part is connected to the high voltage. That means there will be current flow in this diode, and there will be current flow through the diode, this one, and current flow through the diode, this one. That means these two diodes will not be giving any resistance to the current. The current will be passing through the diode, and as per the rule, current follows the path of minimum resistance. That is why there will be current flow through both of the diodes and no current will pass through output, and the output Y value will be equal to 0. This is important, I am repeating it. A is equal to 0 and B is equal to 0, this diode will be conducting because this P part is connected to the high voltage and this is at the low voltage. So, there will be current flow through this diode, there will be current flow this diode also, no current will pass through the output. So, Y is going to be 0. Second case, A is equal to 0 and B is equal to 1. Now, since A is equal to 0, this is at high voltage and this part is at the low voltage. So, there will be current flow through this diode, but B is equal to 1. This is at high voltage, this one is also at high voltage. So, no current will pass through this diode, but due to the current flow through the upper diode, no current will pass through output. So, Y is again going to be 0. This case is important case. I said A is equal to 0. So, there will be current flow through this diode, but B is equal to 1. No current is passing through this diode. So, due to the current flow through the upper diode, there will not be any current in the output and Y is going to be 0. The next part, the next case, that is A is equal to 1 and B is equal to 0. Now, these two have changed. A is equal to 1, no current will pass through the upper diode. Why? Because this is at high voltage, this P part is also at high voltage. So, no current will be passing through this diode, but since B is equal to 0, this part is 0 and this is at high voltage, the current will be passing through the lower diode. So, no current through upper diode, but there is a path for the current through the lower diode and no current will pass through output. Y is again going to be 0. The last case, and that is important and that is interesting, A is equal to 1 and B is equal to 1. This A is equal to 1 means this is high voltage. Both the diodes are on high voltage. So, no current will be passing through this diode. Here B is equal to 1. This P part is also at high voltage. So, no current through this particular diode. No current will be passing through any of the diode. Now, the current path will be through this one, through output, and so Y is going to be 1. Now, A0 B0, Y will be 0. A0 B1, Y is going to be 0, and A1 and B0, Y is going to be 0, but when both A and B are 1, the output is going to be high. As in the definition I said, the output will be high when all the inputs will be high. Next in this sequence will be truth table. Again, truth table is a table showing all input output combinations. The inputs are A and B and the output is Y. Both A and B are 0. When these two are 0, the output is 0. This first case, A is equal to 0, B is equal to 0, Y will be 0. A is equal to 0, B is equal to 1, Y is going to be 1. Y is going to be 0. Yes, because A is 0, the value of Y is going to be 0. The third case, A is equal to 1, B is equal to 0, the Y is going to be 0. And the last one is A is equal to 1, B is equal to 1, the Y is going to be 1. AND gate, a logical circuit with one output and two or more inputs, the output will be high when all inputs are high. I hope this case is indicating the output is high when the all inputs are high. Next point is symbol. Symbol, and the symbol is this one. This symbol is AND gate. This is D, this is more or less, this is the D, straight line, and then this semicircle. This symbol represents AND gate in multiplication in Boolean algebra. Significance of AND gate is multiplication. As I said, OR gate indicates addition, and now AND gate represents multiplication in Boolean algebra. So, by this time I discussed two gates, one is AND gate and the another one is OR gate. OR gate represents addition in Boolean algebra and AND gate represents multiplication in Boolean algebra. Now, next in the sequence is NOT gate, which we will be discussing today, and the gate is NOT. Definition is, the first part is definition. The definition is, it is a logical circuit with one output and one input. This is very important. This NOT gate is the only gate which will be having one input. All other gates will be having two or more inputs. Now, it is a circuit with one output and one input. The output will be complement of the input. Now, complement means if input is 1, the output is going to be 0. If input is 0, the output is going to be 1, right. So, this is a circuit with one output and one input, and the output is going to be complement of input. Circuit diagram. I will be using a device or a component, and that component is NPN transistor. Now, this is a transistor and this transistor is NPN transistor. Here I am connecting 5 volts. This value is going to be input, and here we will be taking output, that is Y is equal to 0. Now, this transistor is NPN transistor, because we understand that in electronics this arrow always points from P to N, and in transistor there are three parts. One is emitter, base and collector, and the base part here is P. That is why this transistor is NPN transistor. Working. Now in working there will be only two combinations. One is A is equal to 0, another is A is equal to 1. Now when A is equal to 0, this diode will not conduct, and if this diode won't conduct, there will be no current flow through this transistor, or I will say the transistor will be providing the maximum resistance, and due to which the value of Y is going to be 1. A is equal to 0, this will be in the cutoff state, no current will pass through the transistor, and the value of Y is going to be 1. The second case, A is equal to 1. Since A is equal to 1, Y will be equal to 0. How? If A is equal to 1, this diode will be conducting, and due to this transistor will be in the saturation state, and the maximum current will pass through this transistor, and the value of Y is going to be 0, because this transistor won't be giving any resistance, and due to which the value of Y is going to be 0. So A is equal to 0, Y will be 1, and A is equal to 1, Y is going to be 0. Truth table. Again I am repeating the definition of truth table, that is a table showing all input output combinations. So there is only one input and there will be only one output. If A is equal to 0, Y is going to be 1, and if A is equal to 1, Y is going to be 0. So a circuit with one output and one input, and output will be complement of input. Symbol. So next is symbol, and the symbol will be a triangle and a circle. This symbol represents NOT gate. Significance, and the significance of this is complement. It represents complement. If input is 0, the output is going to be 1, and if it is 1, the output is going to be 0. That means the output is complement of input. Now we are familiar with 3 gates, and the topic of discussion for this lecture is basically the 3 gates. The gates we discussed are, one is OR gate, the second is AND gate, and the third one is NOT gate. These are OR gate, yes, and we discussed this is representing addition in Boolean algebra. The second is AND gate, this will be representing multiplication in Boolean algebra, multiplication, and the third one is NOT gate, and this will be representing complement in Boolean algebra. Very important, these 3 gates are called basic building blocks. These are the 3 basic building blocks of Boolean algebra or the Boolean logical circuits. That means the Boolean operations will be only 3 basic operations: addition, multiplication and complement. Any of the circuit can be implemented by using these 3 gates. If I say I want to implement a circuit for A into A plus AB, now A plus AB, this is addition, and I know for addition the gate going to be used is this one. This is OR gate. Sorry, this is first we will be implementing for multiplication, sorry, A, B. This is A and B, A, B, and the output is going to be AB. The next I want to add it with A, and the gate to be used is OR gate. This gate is OR gate, and if it is A, the output is going to be A plus AB. This is how the circuits are implemented, and basic building block indicates there will be only 3 operations. that is addition, multiplication and complement. Say I want to draw one more circuit and that circuit is for A plus A bar B. Now A bar, bar indicates the complement operation. This is one is A, the another is A bar, this is A and this output will be A bar. The another is B and these two are to be multiplied. That means the output is A bar into B and I want to add this value to A and the gate to be used is this one and that gate is A plus A bar into B. This is how the circuits are implemented. Any of this can be, any of the Boolean expression can be converted into the circuit by using three gates, AND gate, OR gate and NOT gate. OR gate will be representing the addition, AND gate will be representing multiplication and NOT gate will be representing complement. I will give you two questions, you will be solving it just going through this lecture. First one is I want to draw a circuit for AB plus BC plus AC. Now try this one AND gate, second AND gate and the third AND gate and then you should try A plus B into C plus D. Now I hope one OR gate, the second will be this OR gate and you will be multiplying it with the AND gate. The another one can be A bar B plus A B bar. I hope two NOT gates, one is for A complement, another for B complement, two AND gates that is for multiplication and one OR gate that is for addition. This is how we will be implementing these circuits by using gates, AND gate, OR gate and NOT gate. Another important questions from this topic can be one very simple, explain OR gate or explain AND gate or you can be asked to explain NOT gate. One question can be what are the basic building blocks of Boolean circuits? You have to give the names of the three. Why these are called basic building blocks? Because any of the Boolean circuit can be implemented by using these three gates, right. So question can be what are the basic building blocks of Boolean expressions and then explain either AND gate or OR gate or you can be asked to explain NOT gate. Another important question can be why these three are called the basic building blocks? Because any of the Boolean expression can be converted to the circuit by using these three gates, that is OR gate, AND gate and NOT gate. And another question that can be draw the circuit for these expressions and I hope you are very clear. This will be with the help of AND gate, AND gate, AND gate and this one will be addition, that is OR gate. Addition, OR gate multiplied with the help of AND gate. This is complement, NOT gate, two AND gates and finally the OR gates. Thank you very much.